So in this one, approximate to 4 decimal places, which means we need this guy to be less than, okay, 1, 2, 3, 4 zeros I put here. Yeah, I go back and forth on this. So I think what I noticed after I wrote this problem is that your book, if it's correct to 4 decimal places, your book will only use 3 zeros here. So book. And if I'm wrong about that, I'll tell you, but it's not going to matter on the exam, because I'm just going to put it in terms of get it less than this, and then you'll know for sure. Okay, so, and then parenthetically I say, we're going to say that means that the error, the absolute value of S minus Sn is less than 0.1230 and then a 1. And if you get that, you'll be right. Your estimate will be right up to rounding error possibly. The 4th digit might be wrong. Okay, okay, you guys told me that Bn is equal to n over 8 to the n. Now, this one, this series actually, it's a little harder to show converges by AST, but not much. If you look at the related function, f of x equals x over 8 to the x, that denominator is getting a whole lot bigger than that numerator. It's pretty obvious that it decreases. If you want to prove it, you could use calculus on that. But I'll leave that to you to show that it's going to be, Bn is going to be decreasing to 0, which means it converges by AST, and we're just going to do the alternating series estimation theorem to get an estimate on this sum. So let's write out the first several terms. So the sum, instead of writing down the series, I'm just going to say the sum S is approximately equal to, so the S is the series, assuming it converges. So, okay, what would the first term be? Would the first term be positive or negative, first of all? Negative, because it's negative 1 to the n power, and n starts at 1. So it will be minus to start with, and then what's the first term? Minus 1 over, plugging in n equals 1, 1 over 8. Okay, and then it alternates signs, so plus, what's the next term? Plug in 2. So you're going to plug in 1, you're going to plug in 2, you're going to plug in 3. You're going to, I don't know how many we need to go, I don't remember. We're going to need to go several, though. Okay. So you're going to plug in 1. That's what you get when you plug in 1, and then it alternates to plus. What do you get when you plug in 2 for Bn? Yeah, 2 over 64, or just 2 over 8 squared. And then what do you get? Oh, is it minus or plus the next term? Minus, what's the next term? 3 over 8 cubed. And then plus, because it alternates, what's the next one? 4 over 8 to the 4th. And then minus 5 over 8 to the 5th. All right, let's check 5 over 8 to the 5th. I don't think it's going to work, but this is, in practice, this is how you would do it. So check it. See if 5 over 8 to the 5th satisfies the error requirement. So, okay. What does 1.525 blah, blah, blah times 10 to the negative 4th look like? How many zeros in front of that 1? 3, but then it goes 3 zeros and then a 1, 5, which is bigger than that, right? So we got to go more. What's the next term? Plus 6 over 8 to the 6th. Does that one satisfy? 6 divided by 8 to the 6th power. Oops. Okay, so that means we have 4 zeros in front of it. That will be less. 4 zeros in front of the 2 will be less than 0.0001. We're good to go. So this term right here satisfies the condition. It's less than 0.30 and then a 1. So then you guys tell me, what does the alternating series estimation theorem say to do? So which S subscript what would be represented by these terms added together? S5. So you find S5, you're guaranteed it will satisfy the error requirement. That's it. That's it. So if you're not required to prove that the series converges, all you really need, well, you need one more step than this, but work-wise, all you need is this step. And then it's really nice to show me the scratch work in this case. Oh, show me what this, show me, you don't have to show me what this guy equals. You could if you wanted to, but more importantly, you have to show me that it's less than the error requirement, right? And then you have to show me that, okay, I'm going to sum the guys that come before this guy. That's all it says. It's downright straightforward in practice once you write it in this format. And take that sum. So has anybody done it yet? I'll just leave it to you guys. What does it turn out to be? So negative 0.0987878 is what you're getting. So 1, 2, 3, 4. We're guaranteed it's accurate to here anyway. I mean, up to rounding error, right? So your book might actually round this to an 8, weirdly enough, and then cut this guy off. But I'm not even concerned about that. Just be aware that your book might do something weird like that. Okay? Make sense? Not so bad, right? Digging ditches, a lot worse. You could be doing that this summer. Of course, you might be making money if you did that. I don't know. Eventually, the idea is eventually you'll make money, you know, after you get your degree and stuff.